So we are starting earthquake theory of earthquake, and for that the first question is the definition of earthquake. So it is pretty simple. First, the where you want to answer from, you will start the answer. You have to make your notes using slide 1, 2, 3, and 4. Okay. So where it is written here that earthquake is when two blocks of earth. We know that our earth crust is made of different tectonic plates, which are always moving because the inside of the earth is basically lava or magma. So basically the earth crust, the solid surface, is moving on top of that liquid, high velocity hot liquid. Okay, and these blocks are always moving past one another, and when they are basically stuck to each other, then what happens that there is increase in energy between those planes. Okay, and when that energy is more, then when the energy is really high, then the bond breaks, and there is a sudden release of energy, and this sudden release of energy is basically we felt it as earthquake. So earthquake, this happens below the earth surface. Usually the location below the earth surface where earthquake starts, that is called a hypocenter, and the location directly above it is called the epicenter. Okay, so the hypocenter and the epicenter. Okay. And earthquake is basically the definition. Here you can find that it is written the same thing but in another word. So you can make your note from these slides. Okay. So the second question will be that types of shock. So there are basically three types of shock: foreshock, main shock, and aftershock. When an earthquake happens, we get three types of shocks. Foreshock is basically the smaller earthquake which happens before larger earthquake takes place. Okay, the smaller earthquake that happens before larger earthquake that takes place. But we cannot tell one earthquake is a foreshock until a large earthquake happens. Okay, so basically when an earthquake is happening, we have to be prepared that okay, maybe there will be a main shock. This is the foreshock. Okay, the main shock is the largest shock. Okay, main shock is always the largest earthquake is the main shock, and after main shock there are always some aftershocks. These aftershocks are smaller earthquakes, and depending on the size and of the main shock, there is aftershocks. They can continue for weeks, months, and years after the main shock. So when there was in 2015, there was the Nepal earthquake. So after that, after 1 year also, there was aftershocks. Okay, so the next question is, why do earthquake happen? Okay, so the earthquake happens, I have already explained it, that earthquake happens when there is basically two blocks of rock or plates. Okay, they are rubbing against each other, but they don't slide smoothly. They stuck on each other. So there is one block of earth and there is another block of earth. They are not smooth. So when they are going past one another, okay, like this, when they are going past one another, they will stuck onto each other. They will stuck onto each other. So basically it is like this. So as they stuck to each other, then they are still pushing but not moving. Okay, Then when after a while কি হবে? After a while the pressure that is built inside them that will cause the rock to break. So when the rock will break, they will start moving again and there will be release of energy and they will keep moving until they stuck again. So this way there is always a chance of earthquake. And the place, okay, so focus or hypocenter is the spot underground where the rock breaks, and the place right above or top of the ground is called the epicenter. So if you are asked the question, why do earthquake happen, what you have to do, you have to answer from these slides and you have to give a picture. Okay, this one or this one, you have to give a illustration. And earthquake, the first cause, the first two slides says the cause of natural cause. Earthquake also can happen due to man-made cause. Okay, so earthquake like seismic wave can also be caused due to explosion underground. So if there is we are going to make a tunnel and there will be an explosion underground, this explosion can break rock. Okay, break rock, and this may cause seismic wave, creation of seismic wave. Okay, this underground explosions can like nuclear bomb test. This can create seismic wave very much like large earthquakes. Okay. So these are man-made cause of earthquake. So why do earthquake happens? Earthquake happens due to natural cause and also due to man-made cause. So the next question is the source of earthquake. Okay, the source of earthquake. So we know that basically this is the inside, this is the lava or magma, and this is the earthquake tectonic plates. And they are always these plate boundaries. They are basically these tectonic plates have plate boundaries. Okay, these tectonic plates have plate boundaries. These are basically the boundaries. These are basically the boundaries. These boundaries are called fault lines. Okay, these boundaries are called fault lines. So you can see that this is a world map, and you can see the different fault lines or plate boundaries. Okay, and you can see that here basically Bangladesh lies in this region, and here there are 3 fault lines inside Bangladesh. That's why Bangladesh is very earthquake prone country. So how many types of plate boundaries are there? So there are basically 3 types of plate boundary: divergent, convergent and transform. Divergent plate boundaries are when plates are going away from each other. Convergent plate boundary is when plates are coming towards each other, and transform plate boundary when they are sliding past each other. So if you are asked that type of plate boundaries, you should definitely draw the pictures. So you can see that when a divergent plate boundary occurs. Divergent plate boundaries are continental rifting. Continental rifting means basically divergent plate boundary happens divergent boundary happens between continental plate. Okay, it happens between continental plates. So what happens? There is magma, and magma is pushing the continental crust upward. Okay, continental crust pushing the crust upward. Due to this upward pushing, these plate boundaries are going away from each other. As they are going away from each other, there is a creation of rift valley formation. Okay, so there is a valley formation, and then when they are moving away from each other, okay, then there is a formation of sea. Okay, and as long as they keep moving each other, soon there will be creation of oceanic crust. Then there will be creation of two type of crust. This is continental crust and now there is oceanic crust. Before there was only continental crust. So divergent plate boundary usually happens between continental plates. Okay, continental. So now we are talking about convergent plate boundary. Convergent plate boundary is happens between oceanic crust and continental crust. Okay, so when a oceanic crust and continental crust collide to each other, oceanic crust is basically the denser crust. So we know that something that is denser, that will go under, and which is lighter, that will go up. That is why when we mix water and oil, water goes down because it is denser. Oil goes up. So same thing happens. Oceanic crust is denser. So when they are going towards each other, when oceanic crust and continental crust is going towards each other, then the oceanic crust goes down and the continental crust goes up. And continental convergent plate boundary is a continental oceanic plate boundary. That means this convergent plate boundary usually happens between a oceanic crust and a continental crust. And divergent plate boundary happens between continental. Okay, so this is basically saying that when these tectonic plates, they are stuck along the fault line, then what happens? Sudden breakage of that rock releases energy. Okay, so releases energy, and this energy will stored up energy, release of this stored up energy will be a formation of earthquake. So this energy radiates outwards. Okay, and these faults are on all direction like ripples in a pond. So basically it's saying that if I throw a stone inside a pond, it will create waves like this, right? Waves like this. Same thing when a stone breaks along a fault line, it creates a earthquake in all directions. Okay, so this seismic wave moves through earth and it shakes everything on the ground, okay, along with our house and us, everything on the ground. It shakes everything on the ground. So what are the causes? If you are asked the causes of earthquake, then you can write these are the causes of earthquake. Okay, these are some causes of earthquake. So just read those and write some of them. If you are asked the causes, write down the causes of earthquake in the examination. So the next question is location. Okay, location. Where do earthquakes happen? So mostly earthquake occurs along the edge of oceanic and continental plate. So earthquake usually occurs between the oceanic and continental plate. This earth crust is made up of several pieces called plates, and these plates under ocean are called oceanic, and plates under the continent are called continental plates. So when these plates are moving along each other, they are having friction, and when the stone breaks, there will be earthquake. So usually earthquake happens between continental and oceanic plate boundary. So there is ocean plate boundary, continent plate boundary, ocean continent plate boundary, and ocean continent plate boundaries are the region where earthquake mostly happens. Okay, so just read this. So So usually there are 90% of the world's earthquake and 80% of the 81% of the world's largest earthquake happens along this region. So this region is called the Ring of Fire. So if you are asked that what is a ring of fire, you will answer that 90% of the world's earthquake and 81% of the world's largest earthquakes occurs along a imaginary line in the world map that is called Ring of Fire. And you can see that Ring of Fire is basically this red zone. Okay, and you can also see that this red zone lies along the continental and oceanic crust. This is ocean, so this has oceanic crust, and these are the continents, and this continent has continental crust. So our largest earthquake is happening between this continental crust and oceanic crust, and this region is called the Ring of Fire. And geographical distribution of earthquake. Geographical distribution of earthquake is basically, it is true that earthquake can happen at any place, but there are some places which are more prone to earthquake, like this Ring of Fire zone. So this Ring of Fire zone is basically divided into two sections. One is Circum-Pacific earthquake belt and Mediterranean Asian earthquake belt. So when you have to answer that where do earthquake happens, you have to answer this, you have to write this, you have to write about the Ring of Fire, definitely not the drawing. You don't need the drawing, you just need these lines. And you have to write there are two main belts of earthquake concentrated into two main belts. You have to write down the names of the two belts, and you can write down some of the areas where these two belts basically occurs. Okay, you don't need to write all the names, but some of the names. So this belt includes all the coastal area and coastal area around the Pacific Ocean. And this is extended to Alaska, Japan, Philippines, New Zealand, North and South America. Okay, do not need to write all of the names. And this zone accounts for 68% of the earthquake in the surface. Okay, and the Mediterranean Asian belt. Mediterranean Asian belt begins from the Alps mountain range and passes through Turkey, Iran, Himalaya, Tibet, China, and this is about 31% of the world's earthquake is located in this region. Okay, so just write some of the lines from here. Now we are talking about measurement of earthquake. So measurement of earthquake, we know that earthquake is measured in when we are measuring an earthquake, we are basically measuring two things, intensity and. So when we are measuring earthquake, we are measuring two things, the intensity of an earthquake, the magnitude of an earthquake. Okay, so the magnitude of an earthquake, so let's talk about the magnitude of an earthquake first. So magnitude and intensity are different characteristics of earthquake. The magnitude measures the energy released at the source of the earthquake. Okay, magnitude measures the energy released at the source of the earthquake, and magnitude is determined from the measurement on a seismogram. We will talk about seismogram a little bit later. So our magnitude is basically measures the energy release. Now, so the size of an earthquake is called magnitude. Okay, there is one magnitude for each earthquake. There is one magnitude for each earthquake. So now let's talk about intensity. The intensity of the shaking depends on where you are during the earthquake. So where someone is, that depends on the intensity of an earthquake. So if earthquake is happening, earthquake is generating here, okay, that earthquake will have the same magnitude. But if you are standing in a one-story building 20 kilometers from that earthquake, 20 kilometers away from the earthquake, the intensity of an earthquake that will be different from if you are standing in a 20-story building. Okay, 20-story building that is 100 kilometers away from the earthquake. The intensity, you will feel different intensity in both of the case. You will feel different in this. So intensity depends on where you are during the earthquake. So intensity of shaking, that is varied for an earthquake, but the magnitude is fixed for an earthquake. So intensity measures the strength of shaking. Intensity measures the strength of shaking produced by an earthquake at a certain location. Intensity determines the effect of an earthquake on human or structure. Intensity is related to human feelings. But the magnitude is related to will be related to the energy generation. Intensity is related to human feelings. It has different value at different location for a particular earthquake. It has different value for a different location for a particular earthquake, and intensity varies from 1 to 12 in a scale 1 to 12. Okay, so if in your exam you may be asked to write down short note on intensity or magnitude. Okay, so you may be asked that what is the intensity of an earthquake, then you have to write down this lines. Okay, this line, if you can write this line, that will be enough. So here is an example in just look at one, that in 1885 in Bengal there was an earthquake that was 7, magnitude was 7, and in Dhaka, intensity in Dhaka was 7 and distance of Dhaka was 170 kilometers. Same earthquake with same magnitude, but maybe in Karachi the intensity was different. Intensity was in a scale, it could be 3, it could be 8, it could be from 1 to 12, it could be anything. Okay, so with if you are talking about intensity, you have to fix the place. Here all the intensity are for Dhaka, but the magnitude is the same. Magnitude will be same for if there I write that the magnitude of intensity of Karachi, it will be different. It could be 4, it could be 8, it could be 3. Okay, with different distance the intensity will be different. Okay, so you can see that this graph is basically the same earthquake, 8.7. Okay, magnitude is 8.7 and intensity in Dhaka is 8 and intensity in Mymensingh is 9. So different area, different intensity, same earthquake, same magnitude. It is the Great Indian Earthquake of 1897. So now let's talk about that. We know that earthquake magnitude of an earthquake is measured by seismograph. So now let's talk about seismograph. What is a seismograph? So earthquake is measured using a tool. Okay, earthquakes are recorded by an instrument called seismograph, and the recording they make is called seismogram. So there is two terms, seismograph, seismogram. Picture on the right is the seismograph. This is the machine. This is the tool. Picture on the left is the seismogram. This is the output. So this is the machine. This is the machine. This is the output. The output is seismogram. The output is seismogram. And the machine is seismograph. The machine is seismograph. The output is seismogram. So what is the output? The output is basically it has a frame and it has a heavy weight attached to a pen. Okay. And on the bottom there is a rolling rotating paper drum. What happens when earthquake happens? It vibrates. So as it vibrates, everything attached to it vibrates, but as this pen is attached to a wire, this wire will absorb the vibration. This wire will absorb the vibration of the earthquake and the pen will not move. So pen is not moving, the base is moving. Pen is not moving, the base is moving. What will happen? There will be a creation of this vibration marks. Okay? Seismogram. So it will be, we will get a seismogram. We will get this kind of graph. So this kind of graph enables us to measure the magnitude of an earthquake. How? There is a formula in the math video. I have attached a separate math video. In that math video, you will find out that you can measure there are basically the seismograph. This is a result of a seismograph. You can see the time is started from 0. So after 10 seconds, we will see that this wave is called primary wave. Okay, P wave. And time passing, and after maybe at 21 seconds, there is S wave. So secondary wave. Primary wave is primary wave and secondary wave. I hope you know about primary wave and secondary wave. If not, I will attach a separate video on. There are already videos in the Google Drive link I have given you on earthquake. There is primary wave and secondary wave video. Please watch that video. So primary wave, that is basically in Bengali we say Onudorgho and Onuprostho. Okay. So one wave is like this, and another is so one is primary wave and secondary wave, and after that, at 30 seconds, there is ground motion data. Ground motion. Okay. So when an earthquake happens, first we get primary wave coming from hits the place, then secondary wave hits the place, and then ground motion hits the place. So the time difference between primary wave and secondary wave, we need to calculate the time difference between the primary and secondary wave to do the math problem. So when you will do the math problem, you will see that we need this in the formula. There is a time difference between primary wave and secondary wave. This is the time difference between primary and secondary wave, and this time is required for the calculation. So seismograph allows us to find out the time difference between P wave and S wave, and with that we can find out the magnitude. So by using seismograph we can calculate the magnitude of an earthquake. Okay, so how this earthquake is recorded, you can just give a reading and you will understand. I have already explained this. So there are four major type of seismogram. Seismogram is the output, the graph, and it can be of four types. You don't need to draw the picture. You don't need to draw the curve. Just the names is and learn the names. Okay, learn the four names. You need to learn the four names. So type of seismograph, there can be these four type of seismograph. So if I ask you that what are the types of seismograph, you have to write down the four names. 1, 2, 3, 4. These four names. Okay. So the next question is how you can locate a earthquake. Okay. Location of the epicenter of an earthquake using seismogram. How can you locate the earthquake? You locate the location of an earthquake. Earthquake is happening in one place. How we will locate this place? How we will locate that where this place is? This can be located using a method called triangulation method. This method is called triangulation method. The question can come in two ways. First question, locating the epicenter of an earthquake using seismogram. How we will locate the epicenter of an earthquake using seismogram? The second question is, the second way it can come, let's write down a short note on triangulation method. Answer is same, question is different. Two different questions, same answer. So scientists use triangulation method to determine where exactly the earthquake is. So in this method, there is basically three seismogram. Okay. So there is three seismogram, 1, 2, 3. And each seismogram can measure the distance from an earthquake. One seismogram can measure the distance from an earthquake. So if I just imagine seismograph A. So seismograph A, we can measure from the seismograph that the earthquake is at 10 kilometer distance. So this way, 10 kilometer, we know that earthquake can be in either of these perimeter. Earthquake এই perimeter-এর যে কোনো জায়গায় থাকতে পারে। Seismograph 2 দিয়ে, from seismograph 2, we know that the earthquake is located at 8 kilometer. So we get another perimeter. So first we get one perimeter. Second, we get another perimeter. Using second seismograph, we get another perimeter. So now we know earthquake can be either in this place or this place. Using two seismograph, we get two locations. So earthquake can be either in here or here. So a third seismograph allows us to find out exactly where earthquake is. So these number 3 are three seismographs. It knows that from here we know that it is at 5 kilometer distance. So if we draw a circle again, it will intersect at exact location where the earthquake is. So seismograph আমাদেরকে allow করে একটা earthquake কত দূরে আছে। seismograph থেকে আমরা বুঝতে পারি কত দূরে আছে earthquake-টা। তো তত দূরে আমরা তখন ওই রেডিয়াসে আমরা একটা সার্কেল আঁকতে পারি। এরকম করে তিনটা সার্কেল একটা ফিক্স বিন্দুতে ছেদ করলে সেই বিন্দুটাই হলো গিয়ে আমাদের আর্থকোয়েকের লোকেশন। সো দিস ইজ ওয়্যার দ্য আর্থকোয়েক ইজ। সো এই মেথডটাকে আমরা ট্রায়াঙ্গুলেশন মেথড বলি। দিস মেথড ইজ কল্ড ট্রায়াঙ্গুলেশন মেথড বিকজ দিস থ্রি seismograph forms a triangle. These three seismograph, these three seismograph machine forms a triangle. That is why it is called triangulation method. Okay. So just read this and you will understand. This is pretty simple. So if you are when you will answer the question, you must draw a picture. Okay. you must draw picture. You must write this, you must draw a picture. So seismograph comes handy in locating earthquake because we can see P wave and S wave differently. But seismograph has a limitation. Seismograph has a limitation because seismograph can tell which direction the earthquake is coming from. Okay, so it only gives us the radius. That's why we need 3 seismographs. Using one seismograph, we cannot tell that. We can only tell, using one seismograph, we can only tell that earthquake can be at this distance. earthquake কতটুকু দূরে আছে একটা সিসমোগ্রাফ শুধু ততটুকু বলতে পারে, 5 কিলোমিটার, 10 কিলোমিটার, 100 কিলোমিটার। একটা সিসমোগ্রাফ দিয়ে আমরা বলতে পারি earthquake কত দূরে আছে, কিন্তু কোন ডিরেকশনে আছে সেটা আমরা বলতে পারি না। এই জন্য আমাদেরকে 3টা সিসমোগ্রাফ ইউজ করতে হয়। এটা একটা লিমিটেশন। Okay, so we have come to almost last topics. Okay, not much topics are left. Only 2 questions left. So the second question, second last question is earthquake prediction. So what is earthquake prediction? Earthquake prediction is concerned with the specification of time, location, magnitude of future earthquake. Okay, so if we want to find out that the time, location and magnitude, we want to find out that when, where and what magnitude of earthquake is going to happen in Dhaka city. That is earthquake prediction. So earthquake forecasting. Okay, earthquake. What is earthquake forecasting? Earthquake forecasting is a probabilistic assessment of the hazard. So if a earthquake happens in Dhanmondi, how much devastation, how much hazard will it cost? That is earthquake forecasting. So earthquake prediction is the prediction of the time, place and magnitude of an earthquake, and earthquake forecasting is the hazard estimation of an earthquake. Okay, so you can ask what is the difference between earthquake prediction and earthquake forecasting, and you have to write down the difference from these 2 slides. So now the last topic, types of earthquake. So types of earthquake, you can be asked to write down the type of earthquake based on source. Okay, so based on source there are 1, 2, 3, 4. These 4 type of earthquake, and it has a definition. You can definitely write the definition in your own word. Just read this, and this is pretty simple. Okay, so type of earthquake based on source and type of earthquake based on the depth of focus. Based on depth of focus, it can be 3 types: shallow, intermediate, depth. When the depth of focus is within 60 kilometers from the ground surface, it is shallow. Within 60 to 300 kilometers, it is intermediate, and more than 300 kilometers, from 300 to 600 kilometers deep, it is deep earthquake. Okay, so this is the end of the theories for earthquake, and there are 2 maps I have given in a separate video. So best of luck. That is the end.